In the vast expanse of the universe, signals from space have always been a subject of fascination and intrigue for scientists and space enthusiasts alike. From mysterious radio waves to perplexing patterns of light, these signals hold the key to unlocking the secrets of the cosmos. And now, in a groundbreaking discovery, NASA has reportedly detected a signal emanating from one of Jupiter's moons. This stunning revelation has sent shockwaves through the scientific community as experts race to decipher the meaning behind this enigmatic message from the depths of space. Join us as we dig into the top 10 signals from space. Like, subscribe, and comment on our channel as we focus on this latest development in our quest to unravel the top mysteries of the universe. Number 1. NASA reportedly detects signal coming from one of Jupiter's moons. NASA has broadcasted that the Juno space probe has made an exciting discovery in Jupiter's orbit. It has caught up an FM radio signal from Ganymede, Jupiter's largest moon. The ambassador reassured them that the indication was likely of natural origin. The signal was significantly strengthened because electrons were traveling in a slower rate than their spin. It was also not shocking that they were found near Jupiter's polar areas, since this is where magnetic field lines connect to Ganymede. Long-lasting lunar discharges like this one have never been seen before. It was traveling around Jupiter at 50 kilometers per second. When it was detected, Juno was moving at 111,874 miles per hour. To do this, Juno investigates Jupiter's atmosphere's composition, dynamics, and development. Jupiter's magnetic field lines reach as far as Ganymede, and Juno was recently spotted traveling through this region. The sound is referred to in the field's jargon as asymmetric radio emission. It is a surprising and puzzling discovery that a moon with a magnetic field can cause such a dramatic rise in the strength of waves. Number 2. The WOW signal. In 1977, people on Earth supposedly overheard aliens having a conversation. Astronomer Jerry Eyman used NASA's Big Ear Radio Observatory at Ohio State University to detect the WOW signal, an old radio telescope pointed at the star cluster Chi Sagittarii in the constellation Sagittarius. While looking at the night sky for stars, Eyman picked up a 72-second radio wave burst. He circled the measurement and wrote WOW next to it, hence the signal's name. In the last 40 years, the movement has been used to back up the idea that aliens exist. Scientists and regular people were pleased to see this evidence of alien existence. Huge hydrogen clouds, some of which are millions of kilometers in diameter, encircled the asteroids 266P Christensen and 335P Gibbs. The WOW signal was caught up on a frequency of 1420 MHz, at which hydrogen emits radio waves. The crew determined that the WOW signal was consistent with the radio signals from 266P Christensen, and they verified that comets were present at the time of the signal. Number 3. The Peryton signal. Radio transmissions, both local and galactic, have been studied by astronomers for a long time. Those identified as having originated in the local area are called perytons, and their genesis is generally thought to have to do with meteorological or terrestrial phenomena. While the precise cause of FRBs is unknown, researchers have long suspected these perytons have terrestrial genesis. To learn more, the study team set up a real-time radio interference monitor at the Parkes site and waited for the telescope to pick up on some perytons. Not only was the telescope able to pick up 3 peryton signals in January, but the interference detector did as well, so the team didn't have to wait long. Evidence suggests the source was very similar to a microwave cooker, suggesting further investigation is warranted. Every future site that detects peryton signals will check to see if they are coming from a kitchen, even if it is not certain that microwave ovens are to blame for all peryton receiving. Number 4. The LGM-1 signal. In the cold of winter 1967, radio astronomers at Cambridge discovered a signal that did not match the characteristics of any previously identified astrophysical source. Its characteristics went against the chaotic nature of most astronomical events. The group spent weeks debating whether or not they had discovered an alien society due to the artificial appearance of their newfound home. So when this first occurs, we call it LGM-1, Little Green Men, at least until an obvious explanation is discovered. Like pulsars, radiation from these neutron stars comes from opposing directions, indicating that they are spinning quickly. A brief but pulsating signal is visible whenever one of these beams passes Earth. Currently, there are 2,651 pulsars known to us. Each discovery is assigned to one of the long skinny panels flashing LEDs in chronological sequence. The light patterns correspond with the spinning of the supermassive stellar remnants. Some individuals only blink once or twice, while the average is once every few seconds. Number 5. The Kepler candidate signals from space. NASA's Kepler mission announced it had discovered 461 new possible planets. 4 of the putative new planets are smaller than twice the size of the Earth. Since the last Kepler catalog was released in February 2012, the number of planet candidates has increased by 20% to 2,740, circling 2,036 stars. The previous count of stars with numerous planet candidates was 365, but now it's up to 467 thanks to this discovery. It has been determined that 43% of the putative planets Kepler found have confirmed companions. The high number of multi-candidate systems being found by Kepler suggests a substantial fraction of exoplanets reside in flat multi-planet systems, said Jack Lesauer, a planetary scientist at NASA's Ames Research Center in Moffett Field, California. The Kepler Space Observatory can identify planets by monitoring the dimming or brightening of more than 150,000 stars as potential planets transit in front of their host star. 3 transits are required to establish a signal as a potential planet. Number 6. The Pioneer Anomaly Signal. Approximately 30 years ago, NASA researchers noticed that the Pioneer 10 and 11 spacecraft appeared slightly veering off course, as if subject to some unknown influence. Since 1998, when news of the oddity first circulated among scientists, it has been studied exhaustively and in staggering detail, earning the moniker Pioneer Anomaly and the cult status it still enjoys today. Despite inspiring nearly 1,000 academic papers, innumerable international conferences, and untold scientific jobs, this much-loved cosmic enigma may soon be solved. NASA deployed Pioneer 10 in the spring of 1972, followed by Pioneer 11 a year later in the spring of 1973. Together, the spaceship set out to investigate the asteroid belt, Saturn, Jupiter for Pioneer 11, and the moons of those planets. The probe snapped the first ever close-up images of Jupiter's red spot and Saturn's rings, and measured previously unseen characteristics of the planet's atmospheres and surfaces as they sped by. After the flyby flights were completed in the middle of the 1970s, the Pioneers carried on. The probes were the first man-made objects ever to leave the solar system and journey into the unimaginable cold and darkness of interstellar space. Number 7. The Vanishing Stars Signals. The existence of GCRTs has been kept secret for a long time. Since each GCRT is unique and it is unknown what type of star would generate such a signal, astronomers have determined that 4 GCRTs do not originate from the same source. A new finding adds to the whole body of knowledge that either cements what astrologists already know or adds to it. The finding could also lead to revolutionary new understandings. We can't say for sure if these items are of that type. Numerous questions remain unanswered about them. Telescopes began tracking the Milky Way center at extremely low radio frequencies in the 1990s. However, they didn't come up with any results until the early 2000s, when Hyman's research team combed through data archives from such a low-frequency radio telescope. They stumbled upon the strange signal briefly emanating from the galactic center. The strength of the signal increased over a few months before it finally began to fade. In contrast to many other transient radio signals, no proof of this signal was found in X-ray studies. However, none of them are very satisfactory, the author argues, so scientists continue to ponder the GCRTs and develop new theories. Number 8. The cosmic microwave background radiation signals. The cosmic microwave background is the cooled remnant of the first light that could easily travel throughout the universe. They interpret it as an aftershock of the Big Bang. With time, this original light has dimmed and become so weak that it is only visible in the microwave range. The ESA's Planck mission will identify this first light, which is also the oldest detectable radiation and includes clues to our past and future. It wasn't until 1965 that the existence of CMB radiation was discovered. Using their radio telescope, American scientists Penzias and Wilson detected a signal they couldn't identify in the sky. They concluded that the noise could not have come from anywhere in the Milky Way. It seemed to have begun somewhere in the vicinity of the Great Bang. The scientific community took the results as evidence for the Big Bang theory. According to the theory, even far away from galaxies, quasars, and clusters of galaxies, the shockwave of the Big Bang would be visible as a faint wallpaper radiating from everywhere. The Big Bang theory is the only viable explanation for the observed characteristics of the CMB. Number 9. The fast radio bursts, FRBs, signal. No one gave any attention to a brief detonation picked up by an Australian radio telescope in 2001 from beyond the Milky Way. The fast radio burst, which the strong flare was not detected for over 5 years. FRB. Professor Duncan Lorimer of West Virginia University's Department of Astronomy estimates that the detonation produced as much energy in a fraction of a second as the Sun in an entire month. A recent surge of interest has made the study of these explosions, which occur at the pace of at least 800 per day across the heavens, one of the most active areas of astrophysics. Although the knowledge of FRBs is still limited, we have come a long way in the past year. Despite this, discoveries have led to new questions as experts have proceeded on this journey. Our knowledge of FRBs has recently undergone a sea change. As it turns out, the intense light emitted by an FRB on its journey to Earth includes a record of the intergalactic depths it traversed, providing insights into the nature of galaxies and the medium between them that can't be obtained through any other means. Number 10. The gamma ray bursts. Satellites in Earth's orbit have spotted brief bursts of the most energetic gamma ray radiation known as gamma ray bursts, GRBs, lasting milliseconds to hundreds of seconds. These supernovae occur in distant galaxies, billions of light years from Earth. In the event of a collision between two neutron stars, a short-duration gamma ray explosion is produced. At the very end of their lives, these ultra-dense stars emit gravitational waves before bursting in gamma rays. Although it has been generally assumed that newly formed black holes power gamma ray bursts, a new study by International Team of Astrophysics has cast doubt on this idea. The creation of a supermassive star, rather than a black hole, was found to be the cause of short-term duration GRBs. Researchers are at a loss to choose between two possible theories. First, an extremely massive neutron star is formed when two neutron stars briefly fuse. This star will collapse into a black hole in a fragment of a second. In the second, the fused neutron stars are less massive than they would have been individually, allowing them to survive for a long time. Please like, subscribe, and comment on our channel to stay up to date with the latest news and discoveries from space. Your support is crucial in our mission to inspire and educate others about the wonders of the universe. So let's embark on this journey together. And don't forget to hit the subscribe button.